Hello friends, welcome to lecture number 14, and here we're going to discuss about first shifting property of inverse Laplace transformation, and we're going to prove this property as well, and we're going to find the inverse Laplace transformation, these two, using this property. This is for MSc and BSc students, mathematical physics, right? And before we start, please subscribe the channel if you are new to my channel. Also share with your friends. If you like the videos, then hit the thumbs up button, and you can comment if you have any questions. Okay, I'm gonna provide the link of the previous lectures of mathematical physics, Laplace transformation and inverse Laplace transformation. I have made all the videos on Laplace and inverse Laplace transformation in a single playlist, so I have provided the links in the description box, so you may watch all the videos, because to understand each and everything, every single thing, just it's important to watch all the videos from the lecture 1 to this lecture. Okay, so now let's start. Now, what is the first shifting property? Let me write that one. First shifting property. Right, so here you see, this is the property. If the inverse Laplace transformation of f of s is f of t, right, f of t, then inverse Laplace transformation of f of s minus a is given by e to the power a t into f of t, right? This is the first shifting property. Let me show you how to prove this. Okay, so we know that here you see, if the inverse Laplace transformation of f of s is this f of t, then we can say that Laplace transformation of f of t, right, its Laplace transformation is f of s, and which is by definition 0 to infinity e to the power minus st f of t dt, right? This is the definition of Laplace transformation, right? Let me write it properly. F of t dt, right? So that's what we get. Now, therefore, f of s minus a, what will be f of s minus a? That's gonna be 0 to infinity e to the power, instead of s we're gonna write s minus a into t, then f of t, right? F of t dt, that's what we were gonna get, right? Because this s is replaced by s minus a, so this s will be also replaced by s minus a. So we have understood this, right? So now what we're gonna get, now it can be written as 0 to infinity, and this e to the power minus s minus a, this can be written as e to the power minus s t into e to the power a t, right? You can write that way. So that's why we get infinity minus e to the power s t, let me write it in bracket, then e to the power a t f of t dt, right? That's what we got. Now you see, here you can see that, now compare these things with this, right, and this with this, right? What we can say, so we can say that, here you can see, let me write, this is nothing but Laplace transformation of f of t, right? So this is nothing but Laplace transformation of f of t. So here our f of t is this part. Now compare this f of t with this part, right? Then we can write, just let me clean it, we can write Laplace transformation of e to the power a t f of t is equal to f of s minus a, right? F of s minus a. So here you see what we have done. We have compared this right hand side and left hand side of these two, right? So here you can say this f of s means nothing but Laplace transformation of f of t, right? So here is the definition of Laplace transformation. If you compare this part with this, then you see, then you can say as this is nothing but Laplace transformation of f of t. So this result gonna be the Laplace transformation of e to the power at f of t. Comparing with this, we get that the result. So hope you have understood this, right? And this is equal to f of s minus a. That's why I have written here f of s minus a. So hope you have understood this. So now you see, just wait. So if the Laplace transformation of this is f of s minus a, so we can write using inverse Laplace transformation, we can write inverse Laplace transformation of f of s minus a, that's going to be equal to e to the power a t f of t. We can write that way. So hope you have understood this. And f of t is nothing but we can write this one as well, as like this. F of t is nothing but inverse Laplace transformation of f of s, right? So we can write that way as well. So hope you have understood this result. So this is the proof of this property. Now, let me show you how to use this first shifting property to find inverse Laplace transformation. Let us solve a few problems. Okay. So now let us find the inverse Laplace transformation of these two. Okay. So let me show you how to find that. So solution. So we have to find the inverse Laplace transformation of s minus 8, sorry, not 8, minus 8 plus 8 by s square plus 4s plus 5. So we have to find the inverse Laplace transformation of this. So here you can see this denominator, it can be written this way. So let me show you. It can be written s square plus 4s, then plus 4 plus 1. So this 5 can be written as 4 plus 1. So hope you have understood this. So now you see s square plus 4s, this can be written as 2 into s into 2. Then this 4 can be written as 2 square, right? And 1 can be written as 1 square. So here you see this is nothing but here you can apply a plus b whole square formula. That's going to be s plus 2 whole square, right? Plus 1 square is simply 1, or you can write 1 square. So that's how you can simplify the denominator. So that's why this expression can be written as inverse Laplace transformation of, so here let me write the denominator first, s plus 2 whole square plus 1, right? 1 square. So you can write that way. Then the numerator, here you see in the numerator you can see there is s plus 8. So as we have got here s plus 2, so we can express the numerator this way, s plus 2 plus 6, right? So now what you can do, so here this expression can be written this way. Let me show you. So let me clean this part now. So here you can see, now we can write inverse Laplace transformation of s plus 2 by s plus 2 whole square plus 1, right? Then plus again inverse Laplace transformation of 6 by s plus 2 whole square plus 1 square, right? So what you can write, actually here you see you can write this expression this way: inverse Laplace transformation of this s plus 2 by the denominator, that is s plus 2 whole square plus 1 square, then plus 6 by s plus 2 whole square plus 1 square, right? So again you can find the inverse Laplace transformation separately of these two, so that's why we can write this way. So that is what I have done, and I have skipped these steps, right? So here you see, let me clean this part as well. Now you see this 6 can be written outside, so we can write this expression this way. So you can write this way: 6 into inverse Laplace transformation of 1 by s plus 2 whole square plus 1 square. So what you can do now, here you see. So now you see, if you you can see here clearly, this is s plus 2 whole square, this is s plus 2 plus 1. So you can compare this function as f of s minus a, right? So then your a will be here minus 2, that means s minus minus 2. You can compare like this way, right? If that is the case, then inverse Laplace transformation of this is equal to e to the power at f of t, right? So e to the power at f of t. So here a is nothing but minus a, so here we will get e to the power, here a is nothing but minus 2t, and f of t is nothing but inverse Laplace transformation of f of s. So f of s will be, so here you see, if this function is f of s plus 2, then f of s must be this s by s square plus 1 square, right? So you can write that way. So that means, so if you apply the first shifting property, then you can write here, you can write that this one here, e to the power minus 2t inverse Laplace transformation of s by s square plus 1 square, right? Because you see, inverse Laplace transformation f of s minus a is nothing but e to the power at f of t, and f of t is nothing but inverse Laplace transformation of f of s. So what do you mean by f of s? Now you see, if the f of s minus a is s plus 2 by s plus 2 whole square plus 1 square, then f of s. Now here you see we have got a is nothing but here minus 2, right? If you compare with this, right, minus 2 minus s, you can consider that way, right? So then this is your f of s minus minus 2, right? In that case, your f of s must be s by s square plus 1 square. So hope you have understood these things. So similarly, let me clean this part, just wait. Similarly, you can see this part can be written this way. Just wait, let me clear. So now you see, okay, now you can see this part. If you consider this one as f of s minus a, so then its inverse Laplace transformation will be e to the power minus at. F of t means inverse Laplace transformation of f of s, right? F of s. So here, if this is the f of s minus a, then f of s will be your, and the f of s will be 1 by s square plus 1 square, right? So that's why it can be written as, if we apply the first shifting theorem, this part can be written as 6 into inverse, not inverse, e to the power minus, here also a is minus 2, so minus 2t, inverse Laplace transformation of 1 by s square plus 1 square, right? So hope till now everything is clear. Now let me clear this. Okay, now you see, we know that inverse Laplace transformation of s by s square plus a square, that is nothing but cos at, right? So here you see, here a is 1. If you compare this one with this, then you will get a is 1. So that's why inverse Laplace transformation of s by s square plus 1 square, that's gonna be cos 1t, that means cos t, right? So what we can write, now let me clean this. So what we have got, now you see, let me continue next step from this step here. Let me continue from here. Okay, so we are going that way. Okay, so then what we will get, the inverse Laplace transformation of this, you will get, here you see we have e to the power minus 2t here already, and inverse Laplace transformation of this, we will get that, that's going to be cos 1t, that means cos t, right? Now you see, we know that inverse Laplace transformation of 1 by s square a square, that's going to be equal to 1 by a sine at, right? 1 by a sine at. So instead of a square, if we have 1 inverse Laplace transformation of s square plus, 1 by s square plus 1 square, then that should be 1 by 1, that means 1, right? Sine 1t. So that means we will get sine t, right? We will get sine t. So result of this is sine t. So what we have got finally, the next part, plus 6 e to the power minus 2t sine t, right? That's what we have got. So now you can take this e to the power minus 2t, e to the power minus 2t common, then what are you gonna get? So here you see, then we will get e to the power minus 2t cos t plus 6 sine t. That is our result. So hope you have understood this. That's how we can solve the first one. So now let me show you how to solve this question number 2. So here you see, this is the next problem, how to solve. We are to find the inverse Laplace transformation of s minus 4 by 4 into s minus 3 whole square plus 16, right? We can write that way. So here it gonna be again inverse Laplace transformation. It can be simplified as this. Let me show you how to do that. S minus 3 minus 1 divided by 4 into s minus 3 whole square plus 4 square, right? That's how we can simplify, right? So here you see, then again in the next step what we can write, inverse Laplace transformation of, we can write s minus 3 by these things, then minus 1 by 1 by this denominator, right? So let me show you how. S minus 3 by So here 1 by 4 can be written outside if you take 1 4 common. So you can write that way. Let me show you. 1 by 4, that's going to be taken outside. Laplace transformation of s minus 3 by s minus 3 whole square plus 4 if 1 4 is taken out, and 4 can be taken as can be written as 2 square, right? Then again minus Laplace transformation of 1 by s minus 3 whole square plus 2 square. That's what we have got. So hope you have understood till now. So now you see, so here compare these things with f of s minus 3, right? F of s minus 3. So then its inverse Laplace transformation of f of s minus 3. Here value of a is 3, right? If you use the first shifting property, then you should get minus e to the power 3t f of t, and f of t is nothing but e to the power, sorry, that should be 3t, so that should be 3t f of t, right? Because you see, according to first shifting property, if a Laplace transformation of f of s minus a is e to the power at f of t, right? So what is f of t? This f of t is nothing but 3t. F of t is nothing but inverse Laplace transformation of f of s. So what will be the f of s in this case? Now you see, if this is the f of s minus 3, then f of s in this case it will be s by s square plus 2 square, right? That's going to be the f of s. This is the f of s. So hope you have understood this. So here we can write using this property. Let me write these things here. So using this property, what we can write that okay, so this can be written as 1 by 4 e to the power 3t inverse Laplace transformation of, here f of s, we have I have already told you that if f of s minus 3 is this, then f of s must be s by s square plus 2 square, right? This should be the f of s, right? So now let me clean these things. So similarly, the next part of this, here you see, if this is the f of s minus 3, then f of s should be 1 by s plus s square plus 2 square, right? And if inverse Laplace here you see, an inverse Laplace transformation of this f of s minus 3, that's going to be equal to e to the power minus 3t, sorry, e to the power 3t f of t. F of t is in this case inverse Laplace transformation of f of s, inverse Laplace transformation of f of s, and here is the f of s, 1 by s square plus 2 square. So what we can write, so let me clean these things. So we can write inverse Laplace transformation, sorry, e to the power 3t inverse Laplace transformation of f of s, that means 1 by s square plus 2 square, right? So now let me close the bracket. So hope you have understood this. Now you can see that inverse Laplace transformation of s by s square plus a square, that's gonna be cos 80. That's why in this case a is 2 here. So what we're gonna get, we're gonna get 1 by 4 e to the power 3t cos 2t. That's what we have got. Then minus e to the power 3t and inverse Laplace transformation of 1 by s square plus a square. that is 1 by a sine 80, right? And in this case a square is nothing but 2 square, so that's why what we're gonna get, you're gonna get 1 by 2 sine 2t. That's what we have got, right? So hope you have understood. Now if you multiply the 1 by 4 with both the terms, then what you're gonna get, then your result will be, so here the answer gonna be it can be written as 1 by 4 e to the power 3t cos 2t. You can keep the answer this way as well, and either you can write that way also, or this way, e to the power 3t into 1 by 8 sine 2t. So this is your answer. That's how we can solve. So hope you have understood this. So if you think these videos are helpful, then please share with your friends and hit the thumbs up button. And if you're new to my channel, please subscribe the channel and inspire me to create new contents for you, help me to grow my channel. See you in the next video. Thank you for watching.